Howdy, howdy. We are back to the backend today. In today's video, we're going to be creating schema and resolvers in GraphQL for querying and delivering back time series data. In this video series, we've been building up this stocks and finance app I've been tinkering and dreaming up. And one of the first things I want to add to this app is the ability to have various charts when looking up any particular stock symbol. Maybe I want to be able to see a company's revenue in the form of a bar graph, or dividends or shares outstanding or anything like that. So this would be several different charts that I'd want on screen. In order to display a chart, I need time series data, meaning I need different data points for different points in time for what each value, what each bar should be in a bar graph. So in this episode, we'll design the GraphQL schema that you might use for building out time series and delivering back time series data. And we'll actually be querying the IEX API that we've been using to fetch real revenue for real companies. So let's dive right in. Looking at the IEX APIs, they have, this is just an example API run I'm doing. I won't dive into the IEX API today, but essentially I can provide a symbol, so in this case Apple, a resolution of data, so quarterly, annual, etc., and a time range, so say 5 years. And this is going to deliver me back 5 years worth of quarterly financials. So for September 2022, I can see the total revenue here. For June 2022, the total revenue. For March 2022, the total revenue, etc., etc. So this is the type of data that we can use to build up our time series. So let's dive into our very basic backend that we've built so far. Really, we've just kind of bootstrapped a backend with Apollo GraphQL, and we've been able to deliver a very simple quote for a symbol, giving most recent pricing change, company name, PE ratio, etc. But we really haven't gotten more advanced than that. So let's start with building out the schema that we might want for delivering our time series data. So I've been using a mutation for this quote retrieval. I'm going to try a query today. I might go back and forth in this series until it really feels right. But I'm going to build out a query today to be able to look up a particular symbol and then get various attributes about it. So I'm going to remove our kind of hello world query we have here. And I'm going to make a lookup query. And in this lookup query, it's going to look very similar to our quote query. We're going to pass it a symbol. So this is where you might pass in Apple, Tesla, Google. So I'm going to make this a required string. And then the result of this is going to be a lookup result. And we'll make that required as well. So let's go make what our lookup result will be. So in our lookup result, we'll also return back the symbol itself. So this will be a string that's required. And then let's say for any particular company or symbol that we're looking up, we want to be able to get that time series of revenue. So let's make a revenue field here on our lookup type. And I want to be able to pass in arguments to this field for what sort of resolution I want. So do I want quarterly data? Do I want annual data? So I'm going to use parentheses here, and I'm going to call this resolution. And I'm actually going to make an enum, so we have very specific values that would be allowable in this argument. So I'm going to call this resolution, and that's required. So let's make an enum in GraphQL. and the options will be annual or quarterly. Okay. Now we will return, let's return a, this will be an array because it's time series data. This is going to be an array of data. So let's make the result called data point. So this is just going to be very generic, and we'll probably end up renaming this over time, but we'll start here. So our type data point, because this is time series, it will revolve around a particular date. So let's make a date type. Now, date is not a type that we currently have, and it's not actually a type that's built into GraphQL, but we'll get to that in a bit on how we utilize dates within GraphQL. And then, let's see, now we also want a value. So our data points right now, we're going to assume they're numbers just for the sake of this. So we'll make this an integer, and it's required, and there we go. So I've saved that, and let's hop on over to our, let's see, I think that's good. Yeah, let's hop on over to our Apollo server, and this is the quote mutation that we've been making so far. Hi, Aryan. I'm sorry if I don't know how to pronounce your name. Aroyan. Thanks for your nice comments, by the way. Let's see. So let's build out our query here. I'm going to make a new tab so I can save my mutation. So let's do a, I don't think this has restarted. I'm going to Control-C out of here. Okay, here we go. I expected this to happen, actually. So it is saying expected name found. Oh, I didn't name my enum. That's why this failed. Okay, enum resolution, save. Okay, another error, unknown type date. Okay, here we go. So that is actually good. So we're defining our GraphQL schema here, and everything has to be type safe. But we've defined this date field, and GraphQL doesn't know what a date is or how to resolve it. So in some of our videos, we've gone over GraphQL code gen by this group called the Guild. Well, it turns out they have several different GraphQL solutions for you, including built-in GraphQL scalars, or not built-in, but custom-built GraphQL scalars that will be common to many different applications. So let's go see what they have here. Date and even date time are two of the scalars that they offer. So let's install this GraphQL scalars package and utilize the date scalar that they have. So I'm going to go to Quick Start. We're using PNPM on our backend. So I'm just going to copy this, and we're going to install the GraphQL scalars package. Alrighty. Okay, so we need to define in our type definitions, I call it schema, our scalar name. So here in our type definitions, we already have one for a custom JSON type. So I'm going to say date. So I now have a date scalar. Perfect. But I also need to add the resolver for this date in our resolvers as well. So let's go import from Scalar, GraphQL scalars. Let's take a look at what their imports are. So we have date mock, date resolver. So date resolver is the resolver function that this package provides to resolve dates. So we can see we have our JSON resolver up here. I'm going to add our date one right here. So date resolver and just save that. Now, if we look at our errors, we can see that query hello is defined in resolvers but not schema. So earlier I actually removed our hello query here, but I didn't remove it from our resolvers. So I'm just going to remove our hello world query here. So we'll save that, and now our server is properly booting up. So that's a step. Okay, so let's hop on back over to our Apollo sandbox here, and I was going to type out this query so we could see what it would look like in the real world. Can you see this? Yes, you can. Can I scoot this over? No, I cannot. Okay, so we have a symbol variable here, and let's say we're looking up apple. So we have a query. We have a variable that we're passing in, which is a string, and we're looking at our lookup query. And then the fields that are available on lookup are the symbol itself, as well as revenue, for which we're passing in a resolution. And I'm just going to highlight here, you can either make these arguments set to variables, or you can just type them in the query. So I'm going to remove this resolution variable, kind of cluttering things up here. And I'm just going to set it right here. So rather than, and I can control space and get autocomplete here. So let's say resolution quarterly. Okay, so now I want to get the date and the value to this. So if I run this, we can see cannot return null for non-nullable field query lookup. So our query is working, the types are checking out, but of course we haven't implemented this in the resolvers. So I just wanted to highlight here what this query would look like. So we're looking up a certain symbol, and then the result of that is going to be a symbol and then a revenue field for quarterly revenue over a period of time. So that's what our query looks like. We've got our schema implemented. Let me go ahead and generate our Typescript types for this, and we'll continue on. So we implemented in another video GraphQL code gen to auto-generate TypeScript types based upon our GraphQL schema. And we have a quick script here called generate, which generates those types. So I'm just going to run pnpm generate. And that should generate our TypeScript types. Great. All right, now let's go into our resolvers file here. And we're going to implement the resolvers for our lookup query and then all of the things that it returns. So under query here, I have a lookup field that I can attach here. This is a root level query, so there's no parent object being passed in, but there are arguments. So let me complete this. So the only argument is symbol. So that's good. Now we need to return various things. So let's just mock up some data here. So let's return an object. This is just going to be fake data for now. So we're going to return whatever symbol was provided. And then we can see we have a revenue key, which should return an array of things that are date. And I'm just going to put a date in here, and then a value of a bunch of numbers. So I'm going to save this and then see if, okay, that number's too big. We're going to get there in a second. I'm going to rerun this. Okay, here we go. So we're returning our mock data here, and we can see everything is checking out. But of course, this isn't real data. We want some real data in here. So let's build this out a little further to actually return apples or any other symbols, real data, over a period of, say, 5 years. Now, we're using the IEX API for this, and we installed this in a previous video, and we're initializing the client here. Now, the IEX API unfortunately does not come with TypeScript typings, nor is there community-supported typings. I have been building up the typings for this just today. I am no pro at this, so I'm probably maybe wait to get a little more practice in before I go over this. But I'm building up some typings for this to make it easier to go over this API in this video. So let me show you what I mean. So let me comment out our mock return here. And let's use our client, which is our IEX API client. Client.timeSeries will get us a time series. And thanks to my wonderful typings, we've got several different options here. So the example that I showed you in the beginning is this time series of income data. So that's what we're going to use here, income. And then the key is going to be the stock ticker. So we'll say symbol. And then what else do we have here? Limit, I happen to know this API limits it to 1 result. So I'm just going to go ahead and say, bring us up to 100. Range, I want to say, I want a 5-year range for this. And then subkey, can I remember what that is? Subkey is our resolution. So this is either quarterly or annual. Now it just so happens that in our schema, we are passing in a resolution argument to revenue. So as we can see, I'm typing this in the lookup query, but actually I don't have the resolution argument accessible here because I'm not in the revenue field. So let's instead build this up a little bit of a different way. So instead of building all of the return for this lookup here, let's build this out per field. So what I want to do is I want to do like a partial return here. Let's say I just want to return the symbol. And then somewhere else, I will do this time series lookup. Now, there's a problem with my types here, and then if I do a partial return, meaning I'm only returning symbol, I'm not returning both of these values, symbol and revenue, I'm getting a types error. But you know, if the person doesn't query revenue, like let's say I don't query revenue here, then we don't need to actually do that API lookup. So this often happens in the case of GraphQL where you only want to do lookups and things if the user actually requested that field in their query. Because that's one of the great things about GraphQL is you don't have to request all of the data. You can just request whatever you need for your interface. So how would we build this up? Well, in our GraphQL code generator, we can build up the value for this lookup return. And it can be a special type of object. So instead of returning everything all at once, maybe I just want to have a lookup object that holds the symbol itself, and then I can manually make resolvers per field to resolve each field's value. So that sounds a little confusing. We'll do it right now. So I'm going to, in my GraphQL folder here, directory, I'm going to create a file called types. And for this lookup type, I want to make a type that is actually called lookup. And instead of having both values, I just want to store the symbol in this. So lookup is string. And in our CodeGen configuration here, there are a couple of different configurations we can make. I think I have the docs up on this somewhere. Okay, here we go. So I'm on the GraphQL code generator docs. This was actually a little hard to find, but it's called mappers. So whenever I'm generating a types file for my schema, I can pass in a config called mappers. And this maps a GraphQL type to an existing TypeScript type that I've built in a particular file. So you can see here the naming convention is the file name, hashtag or pound, depending on what generation you're from, the name of the type. So let's do that. Let's make a mappers key here, and we'll say lookup is from the, now this is going to be relative, the path name here is relative to the generated file. So this is going to be up one directory, into GraphQL, into the types file, and then hash lookup. So rather than GraphQL CodeGen building up a lookup type that has every single field on it and required, it's going to use this partial type that I've built here. So let's go ahead and run our generator. Make sure we don't get any errors here. That's good. And then I'm going to go into our resolvers. I'm going to go into this generated GraphQL type. Now, I can see we have some errors in the generated file. So it's properly importing the lookup type from my GraphQL types file, but it's also generating its own lookup type. Now, in our schema file, we're using very simple type names, and these could conflict with other type names I'm making in our backend code. So one common thing that I do in my apps, and I'm looking up the value on this, yes. One common thing I do in apps is for the generated GraphQL types, I have a prefix on those, so it's not conflicting with my other types in my project. So let me show you what that means. So again, in our CodeGen configuration here for our GraphQL types generator, there is another config option called types prefix. And what I usually do is prefix all GraphQL types with GQL. So let me save this, we'll regenerate, and I'll show you what that means. So let's pull back open our generated GraphQL file. So now my lookup type is still importing. I don't have any red squigglies anymore, so that's good. But all of the generated types are prefixed with GQL. This ends up being really nice when used because you don't have to worry about keeping your GraphQL types and your Typescript backend types uniquely named, because often they will have similar names. Okay, so let's see what this looks like now in our resolvers file. So at the top of our resolvers file, we've made a few changes. So instead of resolvers as a type being imported, this is now going to be GQL resolvers. So we're going to change that up, and we can see that that fixes that red squiggly. And also for our lookup query, we're returning symbol here because that's the only thing that's required on lookup, even though there are additional fields that we can return on lookup. So if we're just returning the symbol in here, how do we return the revenue for this object? Well, in our resolvers, we're resolving a type query, we're resolving a type mutation, so now I can add resolvers for type lookup. And this is this type lookup right here in our schema. So we can make resolvers specifically for the revenue field. Now, how do we know what revenue to look up? Well, this is where this first argument comes in, because we're no longer at the root level, we are one level deep. So if I go into my server here, if we've already gone through the lookup query, now we're inside of lookup and we're trying to resolve revenue. Now we have a parent object that we can bring in. So that parent object I'll just call lookup here. And then this has arguments as well. So revenue has arguments of resolution. So if I control space here, it's not going to show me. That's been weird. There we go. Resolution. So resolution is one of the arguments that we have. So rather than doing this time series call up here, I'm going to move this down into my revenue section. And I'll just delete this commented out code. Okay, now we can continue on with our time series API lookup. Okay, but we don't have symbol anymore as an argument, but it is on our parent type. So I can just say lookup.symbol, because that's coming in through the parent object. All right, so let's say this is a result, await. This is not an async function yet. Let's make it an async function. Okay, now what does our result look like? Our result is an array. So we're going to return result dot something. So our result is this array that I'm showing off here in Postman. But it's not exactly the shape we need for GraphQL. The date's not called date, it's called fiscal date, and the total revenue is not called value. So we'll just map over this array and create a new array. So map over this array, and we'll call this each object a point, and we're going to return a new object. So thanks to types, the two values we need to return are date and value. So date, we're going to say, is the fiscal date of this point. And then the value is going to be something about revenue, total revenue. Great. Okay, we're missing one additional thing here. I can see we're not using resolution. So let's see what that is. Resolution is this last item here. Let's see what else we have here. Subkey, that's what it is. Okay, so subkey is going to be our resolution. So let me save that, get this nice formatting, and no errors in the code, at least in VS Code. Let's try running this and see what happens. So, run. Okay. I knew this was going to happen because I tried this beforehand. This is an interesting one. I haven't run into this before because I don't usually deal with numbers this big. But thanks to Apple's incredible revenue, Apple's revenue exceeds the size of an integer that's built into JavaScript. This integer is too big. So I still want to return a number, but it's too big for GraphQL and for JavaScript. So how do we do that? Well, let's go back to this wonderful Graphql-scalars package that we looked at earlier. This is how we added the date type to handle dates. Turns out this package also has a big int type, which allows us to return big integers. So let's make this a scalar in our app. Let me reorder my screens here. We're going to make a big int scalar and return values of our data point. Instead of integers, return them as big ints because they're big. So big, big int, and let's go up to scalar here, and we're going to make a new scalar called big int. And we need to add in a resolver for this. So let's go to our GraphQL scalars here. Big int resolver, big int resolver. There we go. Okay, that should fix it. Let's check it out. Run. Yes. Okay, so check this out. So we're looking up Apple, which is a variable we're passing in down here. We're returning its symbol, Apple. We're returning a time series of its revenue for a quarterly resolution, and we're returning date and value fields from there. So I can see we're getting quarterly, September, June, January, December. So we're getting quarterly values, and we can see the value changing here. Now, if I change this to annual, does this change? And in fact, it does. So instead of getting September, June, etc., we're getting September, 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 September. Annual values for this. So let me change this back to quarterly. Yes, this is awesome. Okay, so this is what we would need. This is the data we would need to return in order to generate UI for a chart here on our front end, which we'll do in a future video. Okay, Aryan has a question. Newbie here, so if user is only a query symbol. Newbie here, so if user is only query symbol, it'll only show the latest data, but if user is using lookup query, it'll query the whole data or something like that. Okay, so Aryan is, I'm sorry, I'm sure I'm butchering your name, is asking about the difference between our lookup query and our quote mutation. So our lookup query and our quote mutation return two different things. Our quote mutation returns a quote result, and it's going to return a specific set of data. This is just kind of point-in-time data for right now. What is the PE ratio of Apple or any symbol? What is its price? What did it previously close at? Between today and the previous day, what is its change and change percentage? So that's just a single point in time. Whereas, so that's just kind of like today's quote. Whereas lookup, it's just kind of a skeleton of a type we'll build up over time, where we might want to look up several different things for a given symbol. So I know that sounds a little confusing right now, but what's going to happen is we're probably going to get rid of this quote mutation and build that into lookup. So if you can imagine, what will happen over time is this will really move down here. So we're looking up a given symbol, Apple. From Apple, we might want to either get today's quote, or we might want to get a time series of revenue, or we might want to get both. So I hope that makes sense. I think it'll make sense over time. So let's regenerate our types here. I think we've added some since then. I've saved this. I moved things around. Let me make sure this is still running. Still running. Great. Now, before we go, there's one other thing I've noticed that I want to clean up just a little bit. And that is that we had this GraphQL type JSON package that we were using for a previous video. But we have this Graphql-scalars package, and it has its own version of JSON. Now, it happens to be based on GraphQL type JSON, which is convenient. But we don't need multiple packages here, so I'm going to say GraphQL type JSON. Let's remove this. So pnpm, is it remove? It's remove in Yarn. Okay, I think that was it. Yes, okay, great, that was it. So pnpm remove GraphQL type JSON. Now instead of getting our JSON type from that package, we're going to get it from this GraphQL-scalars package. So JSON resolver. Great. And then we'll use that as our resolver. So let me save this. Let me generate our types just for kicks. Let's rerun our server, rerun our query, and that still works. Okay, so we've eliminated one package in favor of this GraphQL-scalars package. So just to recap, in this video, we made our lookup query. We made a custom type that this resolves to, and we're returning symbol and then additional field here called revenue with time series data we're looking up live from an API. So where might we go from here? So in a future video, we will actually use this data to build up a chart of our revenue for visual sake. And then also, we'll probably eventually want to cache this data because this is a paid API after all. And if we're only looking up quarterly or annual data, this does not change very often. So every time someone looks up Apple or looks up Tesla or looks up Google, we don't want to be querying the API over and over and costing us money. So we'll end up down the road adding in Redis to our environment and caching this data that doesn't change very often so we can reduce our API calls and speed up our own GraphQL API. So thanks for joining in this video. Hope you check out other videos in this series, and I'll see you again soon. Have a good one.